This question is words and gate. So basically, you are giving n by n to the array, and then if the value is -1, it's considered a wall or obstacle. If that is 0, it's a gate. So which means it's a starting point, technically. If this is infinite, mean empty value, and then we can reuse for further condition. And then, so if that is the empty cell, right? So this is considered a gate, right? So if this is a gate, the four direction, which is your neighbor, we'll consider this is going to be a first step from the gate, right? And then this will be the second step from away from the gate, and this will be third, this will be third, and this will be the fourth, right? So based on this idea, we can use a BFS. So we're going to find out where's the gate. So this will be the one, right? So we're going to, make sure we record the visit cells. So I have a 2D Boolean array. Consider that I'm visit this, so I don't want to traverse again. And based on the new cell, I need to traverse my neighbor for every single iteration until the end. So it's actually straightforward. So let's just start coding and then you will see. So I have a Boolean visit, represent new Boolean rooms.length, and then rooms at 0.length, so n by n matrix. So again, how do I know which cells I'm going to add into the queue? So I need to definitely create a queue. It's going to be integer array, storing x and y. So I will say queue equal to new linked list. So what I need to do is I traverse the 2D array room to find out where's the empty gate. J less than rooms 0.length. So if the room say ij equal to 0, I need to first add into the queue. Second, I make sure I visit these cells so I don't revisit again. So now I need to make sure I have a 4 different direction ready. -1, 0, +1, 0, 0, -1, 0, +1. Okay, so we're starting. So first thing is we're starting the the neighbor at 1, so we don't need to traverse at 0. So I'm going to initialize to equal to level. And then how do I know when to stop? It's going to be until the queue is empty, right? So while queue is not empty, I will keep traversing until queue is empty. And then for every single iteration, I just level plus plus. All right. Okay. So the next step is going to be I need to know which is the current traversal. So for example, I traverse the current gate. So I traverse the first gate. So it's going to be this one and this one and this one, right? So it's going to be size of 3. So the first 3 in the queue are the first step away from the gate, right? When we add a neighbor for this cell, the queue is incremented, right? But we don't want to traverse the next iteration, so we need to know the size for the current traversal, right? So it's going to be queue.size. And then based on the size, I just traverse, right? So I need to make sure what is my current cell, which is represent node. And then again, I need to traverse 4 different directions. So x is going to represent direction at x at 0 plus node at 0, right? And then y is going to be exactly the same thing for direction 1 plus node 1. Okay. So first thing is we need to make sure they are inbound, right? So if x is less than 0 or x is equal to the room start length or y less than 0 or y equal to rooms at 0 dot length, we want to ignore, right? So it's going to be continue. But not just that, right? Especially if the value doesn't equal to positive infinity, right? If the value does not, if the value rooms at xy does not equal to positive infinity, so it's going to be integer dot max val, then max. So if the value doesn't equal to max value, then which means I traverse. And also let's consider the obstacle, right? So if this is a case, we probably don't need a visit array, but let's just, just keep it in the solution, so it's a good habit. Right, anyway, so if the, rooms x and y equal to -1 or we visit the current cell, then we want to continue. So it's going to be exactly the same thing. All right, but I will delete this later. So for right now, I'm going to traverse the first 3 neighbor, right? So rooms x and y is equal to level. And then I want to make sure I need to expand based on the current position. So this will be pretty much a solution. So let's run it. Oh, I see. What else? Visit, where is it? Visit IJ. Okay. Submit. Okay, so the time and space are straightforward. Space is this. Consider m times n, right? You have to traverse all of them, right? And then if the measure is small enough, you just have the constant. But if the measure has really big, you need to add every single cell into the queue, right? So I would make sure I did this and try this again. I think this working definitely, because in this condition, if rooms doesn't equal to positive infinity, I already ignore. So yeah, so I will delete it. Submit. Yeah, that works, right? Okay, so the only reason I want to keep the visit is because, like, when you traverse a neighbor over here, you will definitely revisit the same cell previously, right? So in this way, you can prevent them going through it. Probably, like, since it's somehow the time efficiency is better if I have the Boolean visit array. Okay, so time and space are actually the same. Time is actually straightforward, m by m, and then space is this. So this will be the solution. So if you have a question, leave a comment, and I'll see you later. Bye.